Yeah, Saloni, how are you? Saloni, are you there?
Sir, can you hear me now?
Yeah, I can hear you. You are late. So
Hello?
where? Yeah, I can hear you
Good
clearly.
afternoon, sir. Yes, sir.
Yeah, good afternoon. So
Yes, sir.
where is your batchmates? Everybody is late.
Sir, the link has been circulated on our groups. They will be joining in few minutes.
So I
And
think.
sir, I'll make the group today. I'll make the WhatsApp group today. Matlab, I've made that group. I'll just circulate that link to everybody in the class so that everybody can join, and you can also join that.
Yeah, okay, no problem. If I'm not part of that group, it's okay. But I think the group link should be there. Okay. Okay. So Saloni,
Yes,
do
sir.
you have
Uh,
the attendance sheet with you in any Excel form?
yes, sir. I have the attendance. Yes, sir. I have the attendance. I'll send it on the business analytics group.
Actually, is it in the form of Excel sheet or not? Actually, I just need that.
It is in the form of Excel sheet, and it is in the form of PDF as well.
Yeah, just send me there. Okay. So
Okay, sir. We'll do that.
yeah, so that I can have a look of students, and
Yes,
their
sir.
enrollment number is there also.
Yes, sir. Their roll numbers, their email IDs, and their names.
Okay, cool. So let me start. I think
Yes,
in
sir.
meanwhile, just text them, and if they join,
Yes, sir.
then I can admit it. Okay, in the group.
Okay, sir. Okay.
So let me start. 1 minute. Because it's a 1 hour session, na? Because also a lot to cover. So hope my screen is visible. Just confirm it.
Yes, sir. It is visible.
Okay, so fine. So I think installation of Python, I have already shared one, I think PDF on Classroom. Just check that, and also data structure and introduction to NumPy. I just like to cover it. Okay. And in subsequent class, we will cover introduction to Python and is loading the data in Python. Okay, it's a small, I think just a command, and typically people do use. Okay, so we will cover it in subsequent class. 1 minute. Okay. So where is PPT? Okay. PPT is visible, right? Who is joining? Very difficult. Confirm if my PPT is visible just once.
Yes, sir. The paper is visible.
Okay, cool. So, okay, so the topic is data structure introduction of NumPy in Python. Okay, so it's a base I think you people have studied, and let me cover it once because it's just a base for data analysis and all, and you require a little bit understanding of this NumPy. I think whenever you do machine learning analysis, okay, you require this NumPy, pandas, these all libraries. Okay. So coming to this data structure, because in is there any way to make a mod? I think do you have a knowledge of how to make a mod in this classroom, Saloni?
No, sir. I do not have the idea.
Everyone is joining, keep on joining. Very difficult. So let me find out if there is any way out. Because they are joining in between. So, okay. So coming to this data structure in Python, I think you might have studied C, C++, Java, right? And hopefully I just assume that you people might be aware of these all programming, right? So they do have the similar data structures, right? So it's just a specialized form of organizing and storing data. So whenever somebody tells you the data structures, it means how you are storing data in the structured format. That is your data structure. And one of the example of data structure is array, right? Matrices. Sometimes we store data in form of matrices, rows and columns. But whenever you store data in a single column, right, that is called array. We have some certain elements. The most commonly likely well-known data structure is array, right? It contains a contiguous collection of data items that can be accessed by an ordinal index. For example, if your data is in a row format, for example, in an Excel sheet, your data is typically in rows and columns. That is nothing but it's a matrices, but the single column is your array. So typically you store data in an array format, okay? And that has some collection of items, some columns, okay? And when you try to fetch out the data, we try to trigger out the number of positions. For example, if your stored data has 5 elements, then you start with 0, 1, 2, 3, 4, right? So Python data structure have I think two parts. One is primitive and other is non-primitive, okay? So when we say primitive, so when we say 1 minute, okay, so when we say primitive, it means the one which is there in the machine. For example, float, integer, string and booleans, okay? So I think we all know what is float, floating point numbers, what are integers, what are strings and what are booleans. So when we say booleans, we specify it in terms of 0 and 1, okay? So for example, you want to decide whether you want to give loan to particular person or not. That is yes and no. So you will store data in the form of 0 and 1 for machine learning purposes, okay? That is your data preparation part. So that is one of the example of boolean. Strings are, for example, the names. Integers, floating points, these are all in terms of the numbers, okay? So primitive data structures, when you see the primitive data structures, they are typically they are typically stored in terms of they do have some numbers. For example, they do have some specific way to store it. For example, when you say integers, we have to write int, then only your Python program is going to understand it, okay? Then comes to floating point numbers, for example 3.14. So the decimal numbers which are typically regarded as your floating point, and when we write any floating point numbers, we typically write it double, okay? And boolean is nothing but it's a true false, a binary values. Whenever you want to store a binary values, we typically write a boolean, okay? For example, there is something called logistic regression, okay? So if you have a classification problem in machine learning algorithms, then we typically use this boolean. Then comes the characters, okay? A1, whenever you write in a single quote, that is your character. But when you put the single quote, any numbers or any, you can say alphabets in double quote, it becomes a string. That is your sequence of characters, okay? So these are some primitive data structures similar to C, C++, Java. It's the same, okay? Then comes the user defined data structure, okay? So user defined data structures we have, let me go back. So coming to this user defined, this data structure, user defined, okay, this stack, queue, linked list, and tree. So tree is also important. Okay, I'll let you know how. Stack, queues, linked list, and tree. Okay, these all are user defined data structures which are non-primitive in natures. Okay, so now coming to this user defined data structures, stack and queues. Okay, so when we say stack and queues, stack means, for example, you are trying to create a stack, right? So first you push data. For example, I put out 1, then 2. Okay, so 1 will be the bottom, then 2. This is how it is stored in a stack. But when you try to, empty the stack, then this is called pop operation. Okay, push and pop operation can be done in a stack. These are the two functionality. Okay, pop means which are inserted at the last will come out first. Okay, last in, first out, that is your pop. Okay, but when it comes to queues, you try to put data in horizontal format. Okay, for example, 1 2 3 4 5 6. Okay, so we try to insert data from the front. Okay, and this is your back. So enqueue and dequeue, these are the two operations which we typically do in queue. Okay, so I think it's not that much important, but how we implement, that is important. So I have shared you two Python files. Just check out in classroom dashboard there. Okay, so coming to this linked list. Okay, stack, queue, and then linked list. So linked list is nothing but it's also, you can say, a linear data structure, because you are trying to put data in a linear format, and each node contains two sub elements. Okay, for example, this is one linked list. So the first part is your data, and second part is the reference to the next node. It's typically in the form of link, because it points to some other node. So it is stored data and information of next node. This is how it is done in a linked list, because they are linked with the previous node. That is why it's a linked, and in the list form, because it's a linear data structure. It is stored linearly. Okay, so there is something called head and tail. Tail is nothing but when you stop adding any data, that is your null part. It is not referencing to anything, the null one. But this linked list, this next header is referencing to this linked list, next one. So this is how linked list work. It contains data as well as information of the next linked list. Okay, so linked list, there are different linked lists, singly linked list, doubly linked list, circular linked list, but I am just covering this single linked list. The single linked list will contain node and pointer to the next linked list. So the entire portion is called node, a single node. This one is one node, will contain data and pointer to the next node. Similarly, this is another node and this is third node, and now there is no other linked list, so this is a null. It is not referencing to any other node. Okay, that is why it is null. So computer program is going to understand that the linked list, this is the last linked list, no other operation going to perform on this. Okay, so this is single linked list, which is a linear combination of the data. Okay, so this is how you can represent linked list, which contains data as well as pointer to the next node. Okay, Then coming to the tree. So tree is important because there is one more, I think in unit 5th or 6th, which I can recall in your syllabus, there is something called decision tree. So tree is nothing but this is typically a binary tree. So there is something called a root node, and they do have some leaf nodes. This is a leaf node. They do have two children, left and right. Okay, so each node will have two, you can say, children. Okay, for example, 50 is a root node, has right children 45, and 45 has two children 78 and 30, left and right. And this is typically which connects with this child node, root node with child node. Okay, similarly this 20 has three children. Sometime typically in a binary tree they do have two children. Okay, so leaf is nothing but external node. Now there is no other you can say the extensions, so these are called a tree. Okay, so whenever you take a decisions, okay, for example you want to take decisions, whether I'm just taking a simple example, whether you want to give loan or to let's say you have a 10 people. Now you want to decide which one to give, which person I need to give loan. So based on certain attributes, maybe their educational if you have records of education, salary, their experience, whether they live in an urban or local area, if they do have any other running you can loans. Okay, so if these informations are with you, then you can decide based on making certain trees whether you want to give loan to particular person or not. So the two child, the right one you will say yes, and the left one you will say no, based on those attributes. So in this case, this tree, which is extension of, you can say, the decision tree, can help you decide and take decisions whether you want to give loan to particular person, let's say XYZ or not. So this is very much important. Okay. Now there is something called built-in data structures. For example, built-ins are the one which are already there in a Python, okay, libraries. So the list is the one, means you are trying to put data in an array form. These are nothing but it's an array, okay, of numbers, let's say at index 0, 1, 2 and 3. But within this 3 position, you can say, we do have another list, okay, but inside the list. So you cannot say this is, let's say, L3, L4 and L5. This is entirely one L3, okay, because it's under a bigger bracket. Okay, so linked list can be stored like this. Okay, this is a Python program. Okay, so this is referencing to position 0, 70, 1, 2 and 3. Okay, so this linked list has 4 elements, but their address will start with the 0. Okay, just you have to remember it. In list there is something called a index. The element 3 has got indexed at 0. The element 4 has indexed at 1, but when you put a negative index, it is on -4. Okay, so similarly, let me try to run it. You people are there?
Yes, sir.
Yeah. In between you can ask, otherwise I can't see you people. So let's say 3, 4, 5, 6, 8. Let's say this is one number, and you are saying L4. So what it gives when you write L4, what it will give? इसका क्या आंसर आएगा? Anyone just try. 0 1 2 3 4 8, I think, right? 0
Yes, sir.
1 2 3 4. Okay, let me put L minus 2. 0 minus 1 minus 2 5, it should come 5, I think. 6, I don't know. Okay, 1 minus 1 minus 2. Okay, this is how it is there in a negative form. Okay, let me check. Okay, minus 1, it is starting with minus 1. Positive will start with 0, but negative will start with minus 1. Okay, so this is how you can code in a Python. Okay, then coming to this, there is something called tuple. Okay, so list and tuple look similar sometimes. It's just a a matter of big bracket and a small bracket, right? This one, this one is a small bracket and this one is a bigger bracket. Okay, so tuple and list, they do have as per the requirement you can use tuple and list. I'll let you know where you will use list and tuple, but they look similar. It's just a case of just you put a small bracket. It's also in a single quote. Okay, so these are just a string. Okay, these are also a string putting in a bigger bracket. So this we will say list, but we will call it a tuple. Okay, so now there is something called dictionary. These all are the built-in data structures. So dictionary is nothing but when you try to capture data in a you can say key value pair. Okay, the key and the value. So every key will have certain values. Okay, just see. The key is A, let's say education, or for example we say a loan. Okay, 1 means you are giving a loan, and again not, you can say if it is not loan, if it is 0, then you can say not to give the loan. So key and value, whenever you store data in a key and value pairs, we call it a dictionary with this curly braces. Okay, so this is just a parenthesis, the structure, you can say the way we try to code in a Python. So whenever we say a dictionary, it will have a key and values. For example, in a dictionary, when you open a dictionary, when you just type an apple, they give you what we call an apple. There is certain meanings. Okay, so these all are in the form of key and values. Whenever it is in the form of key and values, we call it a dictionary. Similarly, how we gonna implement dictionary in the form in a Python? Okay, so this is a panda libraries. We typically write import pandas as PD. If you have any Python coding platform, you can just write it like this. And dict1, this is user defined one. You can write dict2, dict5, anything. Okay, this is how you just try to write it. This is your way to present it. Okay, and then you start with curly braces. This is key, name, age and label is the key. These are the 3, you can say, attributes in machine learning terms. We are capturing name of the student, age and the labels. Maybe it is a grade, for example. Okay, so name, age and labels, these are the 3 attributes you are capturing with their values. Okay, so this is how we are making a data frame. This is nothing but a data frame. It's typically in the rows and in the column format. So data frame contains data in the form of rows and columns. Okay, so using the dictionary, you have created this a data, you can say the data structures which is nothing but it's a data set. In terms of machine learning, we have created a single data set having the attributes name, age, and label. These are 3 attributes, and 0, 1, 2 is the 3 records. So we have a 3 records with their attributes. Okay. Then coming to this set, there is something called set theory. You might have studied somewhere in the maths in class, maybe 7th, 8th, 9th, 10th, everywhere, the set theory. Okay. So in the set theory, let's say we have A and B. We have a two elements, A and B. A contains 1 to 5 and B have 3, 4, something to 8. We have these 2 elements. So when you write in a Python, let's say print A dot union, this one, print A dot union of B, A and union of B will give something, and print B union of A, this is method 2, or either you can write print A, this is union, this vertical sign is a union. So there are 3 methods to capture the set theory. Either you want to create a union or intersections, so we have to change. So this union and this small bracket, this is nothing but it's a function. So whenever you see anything in a small bracket is nothing but a function. Here union is a function, union and a small bracket. You have to pass the argument. So you want to create a union of A with B. So you have to pass the B into this function. So this is one method to print A union of B. Okay. Similarly, B union of A and print A union of B. So these all 3 is gonna give you the same results. Okay. So this is nothing but it's a set. Now, what is difference between list, tuple, set, and dictionary? Okay. So just to remember it, list is nothing but it's just a sequence type. Also tuple is a sequence type, but it's faster than list. Okay. Immutable means you can't change it. That is called immutable. But lists are mutable. You can change it. Similarly, set, whenever you try to find out union intersections, just see union intersections, and also it is in unordered form. Okay. And you cannot store non-duplicate items. So this is set. And the dictionary is, I already told you, when you store data in terms of key value pair, just remember it, key value pair. Okay. And sometime in Java it is called hash map. Hash map is nothing but it's a key value. So that is, for every key it will have certain values. That is called a hash map. And typically it is unordered form. So this is a dictionary. So if you have to remember it as a dictionary, just remember key value pair. If you have to remember the tuple, just remember it. The small bracket you have to write it. In the list you have to, in bigger bracket you have to write it. But in a set, when you do perform an operation of union or intersections, that is your set. Okay. And these are the some, the features just to remember it, whether it's a tuple, list, dictionary, or set, by looking at only the data or by looking at only the programming. By looking at the programming, you can say they are performing dictionary or tuple or set or list. Okay. If you remember it, the bracket, the round brackets, the curly braces, and the curly braces. Okay. So now coming to this NumPy. NumPy is nothing but it's just you can say, whenever you try to compute anything, so in NumPy the Python gives you a package for scientific computing. For example, if you have any, let's say, calculator, they do perform scientific computing. Okay. But there is something called machine learning. whenever you try to teach machine certain pattern in the data, how you're gonna teach machine to learn certain patterns in the data, that requires some scientific computing libraries. So that is why this Python is a big hit in the market, because they do perform machine learning with high capability, with high accuracy. That is why people have tilted towards this you can say Python program. We do have many you can say built-in you can say softwares for programming, ML programming, but this Python has got huge functionality to cope up with all the machine learning capabilities and all. So NumPy, if you see this NumPy, when you say 1D array, so whenever you store data in this horizontal format, just see, this is one row, but they have column, how many columns? 1, 2, 3, 4 and 5 columns, but one row. This is called 1D array, storing data in an ordered form. That is one dimensional, only let's say X. But when you see two-dimensional array, we have X and Y, let's say. That is why it is called two-dimensional, because we are capturing the two dimensions. Let's say if it is height and width, let's say it is X and Y. Whenever you capture in a matrix any data in a matrix form, X and Y, it is called two-dimensional array. But there comes a third dimensions, which is difficult. We can still recognize the three dimensions of the data, but it's very difficult to analyze it, the three-dimensional data. So when we capture, let's say, the time series data, we do have X and Y, but also an element called time. That is your third dimensional data. So typically when you see this time series data, they are stored in three-dimensional way, because they do have a time component which makes it a three-dimensional data. Okay, so 2D you can easily visualize it. Okay, two-dimensional, but three-dimensionals require a bit of cognitive knowledge how they are stored, because there is a third element, the third dimensions. So when you learn this machine learning programming, the features are typically the dimensions. Let's say age, sex, salary, and if they do have any, let's say, educational background, all will have one dimensions. So typically in machine learning, the models try to plot the data in the dimensions. So every attributes which you capture in an Excel sheet has one dimension. So we typically deal with multi-dimensional data in machine learning programming. Okay, so that is why it's very important to understand, and that requires scientific computing. And then you require some package so that can be computed, because two-dimensional you can easily compute, but when you increase the dimensions, it's very difficult to compute. That is why it requires some scientific computing libraries. Okay, so coming to this NumPy. Okay, so data equal to np.array. Let me just run it, then you will understand this. Let's say import NumPy as, hope it is working, as np. Okay, this library, let me check. 1 minute. And then data equal to np.array. Data equal to np.array. Hope it is right. So 1 2 3 comma 4. If you write just data, what it gives, just let me run it. Okay, it gives you data in the array form. Okay, this is how you can run it in a Python. Okay, you just import NumPy and you call it a NP typically, and then you store data in array format. This data np.array 1 2 3 4 5, we are storing this data in data, this data. Okay, we are storing all these numbers and then we are running it data. We are saying data, what we have stored in data, this, all these things will be displayed here. Okay, so this is how we run it. Okay, this is simple command, we just require this one, numpy.array. Okay, when you say data.max, let me run this command also, data.max, let's say data.max function. So what it will give, maximum is 4. Okay, the numbers, the array stored is 4, the maximum numbers. So when you say this max is nothing but it's a function because it's in a small bracket. Okay, so whenever you see anything in a small bracket, okay, so it is a function. Okay, so now, so this is just a simple command. Okay, so here data equal to np.array. Okay, 1 2 3, these are the 3 numbers which are in the array form we have stored in the data. Okay, we have stored in the data, this data. Now data contains 1 2 and 3, and when we say max of this 1 2 and 3 which is stored in data, this will give us 3 because the max of this array is 3. Okay, similarly how your array is stored, this is typically stored like this vertically. Okay, and the command is np.array. So when you run np.array, the data will be stored like this, 1 2 and 3. Okay, similarly np.ones3, we need 3 ones. So ones is a function and we are saying just print 3 ones. So 1 1 and 1, it will print for you. This is ones is a function. Similarly zeros 3, we need 3 zeros, so we used np.0. so this zeros and a small bracket, this is just a function, so it will give us 3 zeros in this like this. Similarly we want to print 3 random numbers, np.random.random, this random 3 is a function, so this will give us 3 random numbers. It's in in a floating point numbers, so for every single one it will give you different numbers. For me it may not give these numbers. Okay, so this is nothing but a random numbers. So let me run if it random works or not. np.random, let's say I need 4 random numbers. What it gives? It gives different random numbers. Okay, in a decimal format. So this is how you can run it. Similarly, your data contains 1 and 2 here. Data equal to np.array means now data contains, now your data contains 1 and 2, and we want to print 2 ones. So now it is giving me 1 and 1, 2 ones. Similarly, if we add up data plus ones, 1 2 plus 1 and 1, it will give 2 and 3 because they have added it. Okay, so this is a simple you can say the addition, that is arithmetic adding, you can subtract it. Similarly you can also write np dot, let's say random 3, 2 numbers, this will give 2 random numbers and then you can add up. Okay, so these are 2, you can say the function here. Ones is a function, just remember it. Whenever you write anything in a small bracket, It's a function, or we typically in a Python we call it a method. Okay. Similarly, we want you can say subtraction. Data contains 1 and 2 and we want two ones to be subtracted from the data, which is giving you 0 and 1. Similarly, we want multiplication. Data star data will give you 1 and 4. Similarly, we want division. Data divided by data, this is gonna give you 1 and 1. And if you want to multiply the entire data with certain constant, this will give you the numbers. So the way you want to calculate anything as per your requirement, you can do it, you can manipulate it using NumPy. Okay. Similarly, you want to index it. Okay. You have a 3 data 1, 2 and 3, and you want to print the position of 0th position. So data is stored is 1. Similarly, 1th position. Similarly, you're up to 2. This is just a stopping line up to 2, and this is like removing 1 and print all those. Okay, apart from 1, this is just a apart from 1. From this, just this will eliminate this position and then print 2 and 3. So these are the some commands in NumPy. You can use it as per your requirement to print the data, to display the data. So sometimes there is something called data visualization. So whenever you require any data in some visual form, you can leverage this NumPy, because this will give you a lot of benefits for displaying the data as per your requirement. Okay, and this will also help you when you code any machine learning algorithms, because it's nothing but it's just a representation of your features. You just want 2 features, let's say. You just want not first, you just want to neglect the first and then you want another 2. Then this is how you can print it. So when you display data from the Excel sheet and you require some rows and some columns, and you don't want some rows and columns, in that case you require this kind of a NumPy, addition, subtractions and some functions. Okay. This will help you the indexing part. Now coming to aggregation. Your data is stored. Max is nothing but it's just a function. You want a max of the data stored in 1, 2, 3. Similarly, min, it's a smaller one. You just print data, whatever you stored in the data, and then you print data.min. Will give you 1. The minimum is 1. If you want to print the sum, it will give you the sum of the data which are stored in the array form. Similarly, if you want the result of multiplying all, then PROD product, dot product you will write it, then it will multiply it. Similarly, if you want the standard deviation of the data, for example, let's say there is 30 student in this class and you want their age in some standard deviation form, how the mean age is deviated from, how your age is deviated from the mean, then you require a standard deviation. Okay, so it will give how the age of the students are deviated from the mean value. This will give us the standard deviation, which is nothing but the deviation from the mean value. Let's say the mean age of the student is, let's say, 25 years, then it will give you how many students are deviated from the mean. Okay, left and right mean. So a standard deviation will give you a kind of a descriptive analysis. So in descriptive analysis, the NumPy give you better result, right? So coming to this dimension creating, how, if you want, let's say you have stored 2 arrays, 1 and 2 and 3 and 4. So it's in the 2-dimension form. Dimension creating, you want to create a 2-dimensional data. How you will create it? First you will store the element in the first dimension. It's in the first, let's say, rows, and in the second rows. When you add a first rows and second row, it will give you the rows and the column. 0th column and first column, 0th row and first row. So these are nothing but it's a one dimension data, you can say two dimension data. Okay. Similarly, you want to add, let's say, three ones and two these columns. Okay, so this have a stored ones. Similarly, 3 0 you want in a two rows, two columns. This is how it is stored. If you want some random numbers, this will store like this. So just try to run it, because it will give you the way how you represent the data, how you multiply the data, how you can increase the dimension, decrease the dimension. This is nothing but a kind of a visualization of the data. How you can visualize the data as per the requirement. Okay, so the NumPy, in every machine learning algorithm, when you write in a Python, you will see there is starting part, import NumPy as a NP, import Panda as a PD. These are the some default libraries you will use it. But you remember it what these libraries does, because they do have a lot of a scientific computing part. Okay, so that is why it's very much important. Coming to this arithmetic, whether you want to add, you have already added it because it's a two-dimensional now data. So now two-dimensional data, you want to add it. Okay, the rows and columns, you have to add data plus one row. You just want one row to be added. Okay, so one row is added to the entire this matrix. Okay, so this is typically we perform these arithmetic operations using NumPy in a Python. Okay, so matrix means obviously rows and column. This will give you a matrix. Okay, an array is nothing but a single dimensions of the data. Okay, similarly, rows and column, we call it data as a, now we call it a matrix. Now it's no longer a single array, because one more dimension is added. Whenever you add one more dimension in an array, it becomes a matrix. And now you want max of this matrix, it will give a 6, because 6 is the number which is bigger one, right? Then similarly, the mean, sum, we want just max of x is 0. So this is how 5 and 6. Okay, so max of this axis will give you 5 and 6. Similarly, this on axis 1, the max. Okay, so this is typically when you run it in a Python, this will give you the idea how you can perform, you know, NumPy, the scientific computing, which is very I think it's such a important to know, because it's just a basic. Okay, and you can run it. I mean, just store data and then you just run data.max in a Python. Okay, this will give you a result. Okay, now there is something called transposing. Transposing means when you just convert rows into columns and columns into rows, we call it a transposing. I think you can recall in class 10th there was some transpose of the matrix. Okay, maybe which I can recall it. So when we were storing data in a matrix form, we had a lot of mathematical, I think, I don't remember it, but it was transposing of the matrix. Means we were converting rows into columns and columns into row. So when you write data.t, t means nothing but it's a transpose of the matrix, which is now called a data, which is just tilting the dimensions. Okay, 1, 3 and 4, 2, 4, 6 rows into columns. Similarly, we want to reshape it. Okay, so it will just reshape it. Okay, you want 2 and 3 columns. Okay, 2 rows and 3 columns. Similarly, 3 rows and 2 columns. It will reshape the data. So more you can see this and the data visualization techniques here, because the visuals more you see, you got to understand how the data is stored when you use NumPy. Okay, so this is all from my side. Okay, if you have any questions, you can ask. Any questions so far? Yeah, class, any question?
No, sir.
No question. So have you access to this class room, that class board, Google class board?
Yes, sir.
So I have just stored something. Just check that.
Yeah, sir, it was received.
What was that material? What was that?
Sir, about the data types in Python, it is written.
Okay, just try running it, because you just need to run it. Just run using any Python, softwares if you have any. Okay, 1 minute. Let me just, yeah. One more lecture too. I have just sent you there. Okay. So why people are less? People are very less. Are you there?
Yes, sir.
Why people are so less? I think 11, 10 people are here. Okay, so I have just taken the attendance. Okay, I think. Okay. So thank you. Then
Okay,
we
sir,
will
thank
connect.
you.
Yeah. Then we will connect on Friday again. Okay.
Yes, sir, right.
Yeah. I have shared you the PPT as well. Just try to run it, and then we will see if you have any questions. Then you can ask. Okay.
Okay, sir, thank you.
So okay. Thank you.